Ave Coders. In this tutorial, we'll analyze the machine learning algorithm known as KNN, or K nearest neighbors. K nearest neighbors algorithm belongs to the cohort of supervised learning algorithms and is used for classification and regression problems, but the latter is much less common than the former. What is the essence of the algorithm? By the way, from now on, I'll simply call it KNN for brevity. So this algorithm builds its inference based on how similar the training observations, that is, those on which the algorithm was trained, and new incoming observations are. That is, the more similar the values of these observations are, the more likely they are to be classified by the same label. There are some assumptions about the data to which the K nearest neighbor algorithm is applied that are worth mentioning. First, the data itself is assumed to have a low level of noise. Of course, the data must be labeled. There should be no irrelevant features in the dataset. Also, the data should be divided into explicit distinguishable subgroups. Well, just a tip. KNN is not a great solution for large datasets because it could require significant computational resources to process this huge amount of data, and of course it will take time. Let's take a look at a simple example. Here the green dot is our test sample, that is the data that we're trying to classify. It will either be classified as a blue square or a red triangle. And in this example, it all depends on K. With K equal to 3, our sample will be classified as a red triangle because in the vicinity we have 2 red triangles and only 1 blue square. With K equal to 5, our sample will be defined as a blue square because now we have 3 blue squares and only 2 red triangles within this extended radius. Okay, without further ado, let's implement this algorithm using the Scikit Learn library. Alright, so you can choose your own favorite IDE. I've chosen the Google Colab, and first of all, we'll start with importing the required modules from the Scikit Learn library. In particular, from Sklearn datasets, we will import the dataset we're going to be working with, which is a famous Iris dataset. Then from the Sklearn neighbors, we'll import the classifier itself. So K nearest neighbors classifier, K neighbors classifier. And of course, we'll need some metrics to understand how well our model deals with the problem. So we'll import metrics from Sklearn library, and mostly we're going to be dealing with the accuracy for this simple example. Also, we'll need to import matplotlib so we can plot the results, our accuracy, and we'll also need to specify the magic inline method so that our plots will be displayed not in the new window, but within the same notebook. We might add some more imports along the way, but first let's run this cell and we need to have a look how our data looks like. For that, we're going to specify Iris as a data object. If you wish, you can display its type. Its type will be the so-called bunch container object, which exposes keys and attributes, and it allows us to access the data in that object by key and by attribute. It's a small data set, so we can display the whole data that it contains. So it has 4 columns, therefore 4 features. So which features are they? We can easily find that out by using the feature names method. So because this is a data set about flowers, the features are, of course, sepal length, sepal width, petal length, and petal width. So basically the idea is based on the values of these 4 features, we need to classify our flower, our iris, into 3 classes, which represent the types of irises. So we can display them with target names. As you can see, it's setosa, versicolor, and virginica. And finally, let's have a look at the overall shape of our data. So the data set we're working with, as you can see, it has 150 rows and 4 columns. And now we're ready to split our data and feed it into the classifier. So axis will represent our data points, our observations, and Y's will represent the labels. So this is something we're trying to classify our axes into. And now we're ready to split our data. The Scikit Learn library has a dedicated function to do so, which we'll need to import. So here at the top, we import from Scikit Learn model selection, we import the train test split. Don't forget to rerun the cell after you've done the edits. Once again, in one of the previous lessons, we were studying this function quite in depth. So here I will only remind you that its output needs to be in a certain order, and it needs to represent 4 variables, which is xtrain, xtest, ytrain, and ytest. This is the way we split our data. Then we feed our data and labels into this function together with the test size parameter. So we need to specify its value, which in our case is going to be 0.2 or 20% we will dedicate to the test set. And we also need to specify a random state with a number, so an integer 42. Doesn't really matter which one you put there. This is for reproducibility of our split. Let's print out how our data looks like now that we had a split. So if you remember, we had 150 rows and 4 columns, but after train test split, we have put some to our train data and we set aside 20% to our test data. So it's going to be 120 for the train and 30 for the test sets. But the number of columns, the number of features, of course, remains the same. Now we need to specify the value for k, so the number of neighbors you will take into consideration when classifying the data point. So I don't want to hard code it from the start because I don't know which k value will be optimal. So I'm specifying the range. So we'll go from, let's say, 1 to 10, and we will supply the value of k into the classifier, and we'll look at the result. So scores will be the dictionary where k is going to be the keys and the values will be our accuracy scores. And then we also need to specify the scores list, which will contain just the accuracy scores. And now we can loop over that range. So we type for k in k range, and then within that loop, we define the classifier and it will receive the k as its argument. And after we've done that, we need to fit our training data to our labels. To do so, we'll use the famous Scikit Learn method fit, where we'll supply x train and y train. And down below, we need to use the predict method, and we're going to put our, this time, test data into this predict method. So in essence, we tell in the classifier, all right, you've seen the training data, you've seen the training labels. Now you need to predict or classify the test data. So attach a label to our test data, and we'll populate the scores dictionary with the metrics accuracy, and also our scores list. We'll just append the accuracy scores to that list. So as you can probably judge by the arguments we supply the accuracy score method with, we will be displaying how well our model predicts the test data labels. I have noticed that I've mistyped the scores. It should be equal to the curly braces. Now we run the cell and we can display the scores. Your scores might be different. I've already run this notebook a couple of times in the preparations for this lesson. Therefore, I'm getting the 100% accuracy score in all cases, but one where k was equal to 7. It's great to judge the model's performance by the numbers, but it's even better for the readability to actually plot the result. So once again, matplotlib. The first argument is the x-axis, so the range of k, so the value of k, and y-axis is the accuracy. For the labels, we need to put some labels, of course. The number of k for the x-axis label and the accuracy for y-axis label. I've mistyped the y label. Let me correct that and rerun the cell. And as you can see, I've got almost an ideal result, and this little slump is quite normal when we try to describe the model complexity with the accuracy. But I hope by now you pretty much get the idea of how it works. What we can do next is we can pick the value of k, which we think is optimal. So in our simple example, and in our case, this is any value but 7. So if I'll pick the value, for example, k equal to 3, this will be good enough to rerun the classifier with, well, k equal to 3 or number of neighbors equal to 3, and we are sure that we'll get a decent result. So let me do so. As you can see, I've reestablished our classifier this time, hard coding the number of neighbors to 3. Then I did the fit. Now I can specify the classes. This is the dictionary where keys are 0, 1, and 2, and the values are the types of irises, so setosa, versicolor, and virginica. Then we need some arbitrary data. This is some synthetic data previously unseen by the model that we'll try to classify. Now we do the predict with the new data. And now we can print our model's predictions. So in the first case, model thinks this is versicolor type of iris, and in the other case, it thinks it is setosa based on the number of neighbors equal to 3. So this was the basic overview of how k-nearest neighbors algorithm works on the famous Iris dataset using the Sklearn or Scikit Learn library. And that was V. Please give this video amper's thumbs up, toll the bell, and subscribe to the channel, and I'll see you in a bite.